Module 4, Lesson 9, Writing Addition and Subtraction Expressions. So we've spent a lot of time working on the relationships between the operations, getting used to the idea that we can replace numbers with letters and letters with numbers. Now we're going to start moving towards representing mathematical phrases as expressions. So we are going to be looking at, we're not going to do so much with the real life situations, but we are definitely going to be representing situations using mathematical expressions. The real life situations will come later, but we're going to get used to the vocabulary, the terminology that is used for mathematical expressions. Not going to do as much with comparing or experimenting. We're definitely just really going to get used to the idea of writing mathematical expressions. So today you want to be able to write expressions using numbers that are going to record addition and subtraction operations. So we're not even going to play so much with the variables today. It's going to be focused on more of just the number aspect. That doesn't mean we won't see variables, but focused more on working with specific situations. All right, so we're going to start out. We're going to take a look at a bar diagram to show 3 plus 5. And of course, throughout the video, you want to pause, complete activities, make sure you do some thinking so that you have a richer learning experience. So think in your head, how would you create a bar diagram to show 3 plus 5? Well, I would put 3 down, and then I would add 5 more. 3 plus 5. So how would it look if you were asked to show 5 plus 3? Well, in my head, I'd put down 5, and then I'd put down 3 more. And I'm pretty sure that I've actually got too many pieces here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, I've got too many pieces. I'll have to fix that on the slideshow. But you get the idea here that we would put the pieces down and we put the other pieces with them. Are the two expressions equivalent? Well, the bar diagrams, the tape diagram here shows they're going to be the same. Yeah, 3 plus 5, 5 plus 3 both have a sum of 8. Like I said, sorry about the bars being off there. I'm going to fix those. So how could we show an expression, how could we write an expression to show a number increased by 2? Now here we're stepping a little bit into variables because they're not giving us a specific number. They're saying any number. And we're going to take that any number and we're going to increase it by 2. So how would you write an expression for this? Now remember, expressions have numbers, variables, operations. Well, we have some number, and we have to use a variable for that. And I would like it if we got into the habit right out of the gate here, right at the start, of saying A will be equal to some number. Let's start saying what these variables are going to represent. So there's going to be some number, and I'm going to increase it by 2, or I will have 2, and I will increase it by some number. Now, is there a way to prove this with a bar model, or a tape diagram, or some other model? If you can think of a way, go ahead and illustrate that. If not, here's a way you could do it. I need some part of my bar model that is going to just represent some number. I have no idea what the number is, but it's that number. And then I've got pieces that I will call equal to 1. So some number increased by 2. And here we have the commutative property, switched it around. I've got 2 increased by some number. So now let's take a look at showing the sum of m and k. And it says here to write an expression. So start out with that. And hopefully in your brain you're like, hello, pretty easy here. M plus k, or k plus m. It's important to point out that there are lots of different vocabulary words that can be used to indicate addition, subtraction, multiplication, division. And you'll probably want to read carefully and think about, what do these vocabulary words mean? Are they telling me to add? Are they telling me to subtract? In this lesson, of course, we're focused on adding and subtracting. In other lessons, you might have all 4 operations. So start thinking about the vocabulary that's being used here. Can you think of a way to represent this with a model? M plus K or K plus M? Well, hopefully after the last example, you're thinking, well, I need a piece that is going to be M and K that's going to, sorry, a piece that's going to be K. Of course, I would love it if you actually had K is some number and M is some number. And then we are showing that we can take those some numbers and we can combine them to get a sum, a total. So we've looked at a few examples for addition. Let's think here for a minute. How can we show 10 minus 6? And let's work with a bar diagram. How could you show 10 minus 6? Well, the first thing you're going to need is 10. Hopefully I have 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I got that one right. I've got 10. Now I have to somehow have a way to show that I am taking 6 away. Well, I am a fan of just crossing out those pieces. It's quick, it's efficient. So we had 10, and we are going to cross out 6 of them. So what expression, what would you actually write to represent this model? And hopefully your brain says to you, well, I would write 10 minus 6. I had 10, I took 6 away. Now, if you were to draw a comparison model, because subtraction does have a comparison meaning, I would be comparing 10 and 6, and I would be looking and saying what is different between them. And I would say that this part is different. So I would focus and say, what is this part? And this is the part that is different between the two, so it would be 4 pieces. So a comparison look at 10 minus 6. Could we also do 6 minus 10? Could we use this model for 6 minus 10? Well, hopefully your brain is screaming at you that this model is not going to work in that situation. I would only have 6, and I would have a real problem taking away 10. The model doesn't match that. This model is showing 10 with 6 removed. It's not showing 6 with 10 removed. All right, so how could you write an expression to show 3 less than a number? And this is one that gets students every time. 3 less than a number. So think this one through carefully. Well, the first thing you'd want to do is draw a diagram to model the subtraction. And this is a great question to think about. Are we taking away the 3, or are we taking away the unknown number? What are we actually subtracting? Well, it says less than a number. So I have a number, and I want less than that number. How much less? I want 3 less. So I have a number, and I'm going to take 3 away from that number. So here would be the model. I had a number, and I have less than that number. So an expression for this would be, I have a number, and I am 3 less than that number. I have taken 3 away from it. Like I said, this one is one that really gives students trouble. You're going to want to really think about any situations you run into that involve 3 less. And not just 3 less, but any number less. So how would we write an expression to show the number C being subtracted from the sum of A and B? Now right here you should notice we're going to have a subtraction operation and an addition operation. We're going to have 2 operations in our expression rather than 1 operation. So we need to read this. We need to ask ourselves what's supposed to be happening first, what's supposed to be happening second. Anytime we have more than 1 operation, we have to read the story and get the idea of what events happen in what order in the story. It says here we're going to have the number C, and the number C is going to get subtracted. It says it's going to be subtracted from the sum of A and B. So as I read this in my head, I'm thinking, well, it says C is supposed to be subtracted from a sum. So I need a sum first. I need a sum of A and B so that I can subtract C. So in the story, we read and we find the sum of A and B first. And there are, of course, different ways we could write that. Both of them, we've drawn models to prove that it doesn't matter the order. And then we need to show C being subtracted from the sum. Once again, cannot emphasize enough the importance of reading the situation and asking yourself, what order do these events happen in? And then we have to write an expression that matches that order. So here's a different look here, an expression to show C minus the sum of A and B. Now in this case, it still says that we want to do the sum of A and B because we're going to subtract what? The sum of A and B. But we want to add A and B together first. And then we want to have C minus that sum of A and B. Now, if I write this, is this going to be sufficient? Is this going to say add A and B together and subtract them from C? Well, hopefully your brain is screaming at you that if you followed order of operations, you would do C minus A and you'd add B. Hopefully your brain is saying to you, hey, we really need these parentheses. Why are the parentheses necessary? Well, because if I write C minus A plus B, I'm going to do C minus A, and then I'm going to add the B on. But it says it's supposed to be C minus the sum of A and B. Without the parentheses, only A is being taken away from C. The expression says that A plus B should be taken away from C. So replace the variables with numbers to see if C minus A plus B is the same as C minus A plus B. So we're going to do some substitution here. I'm going to have C be 10, and I'll have A be 5, and I'm going to have B be a 3 for us. So I've got C, which is my 10, minus A, which is 5, minus B, plus B, which is 3. And 10 minus 5 is 5, plus 3 simplifies to be 8. Now, let's put the parentheses in. So I've got 10 minus 5 plus 3. Order of operations says to do those parentheses first. I've got 10 minus 8, which would give me 2. These two things are not the same. Those parentheses are very important. All right, quick look at some exercises here. Write an expression to show the sum of 7 and 1 5/10. Now, I would really like it if in your heads you were thinking, how could you draw models of these? How could you demonstrate these things? But sum tells me I'm performing an addition operation, so 7 and 1 5/10, or I could do 1 5/10 plus 7. Write two expressions to show W increased by 4. So I have a W, and I'm going to increase it by 4. And of course, the commutative property, I can flip them around here. Bar models, I've got W, and I'll increase it by 4, or flip it around. I've got W, and I could increase it by 4. Write an expression to show the sum of A plus B plus, sum of A and B and C. And of course, your brain should say, hey, that's addition. And of course, there's lots of ways we could write this. I could write A plus C plus B, and I could write B plus A plus C, and I could write B plus C plus A, and I could write C plus B plus A, and C plus A plus B. Got lots of ways we could write this one. Lots of ways to make models, too. So a model showing 3 less than P. And I remember Mr. Ludlow saying, I have to read and think about these very carefully. 3 less than p. So in my head here, I'm thinking I've got p, but it says I want less than p. I don't want the whole thing. It says I want to take 3 away. So I'm going to take a section here and call it 3, and I'm going to cross it out, and I'm going to actually change this drawing to indicate that this whole thing is p. Or I could do what I did earlier. I've got p, and I'm going to put 3 x's on it to show I'm crossing out 3. Those x's could be really confusing, though. Am I doing multiplication problem here? So it's probably better with the subtraction to actually say that all of this is p and that you are going to remove 3. And this would be what we'd actually get when we subtracted. Exercise 5, write an expression to show the difference of 3 and p. Now, some of you might be looking and saying, doesn't that look an awful lot like the last one? The last one said 3 less than p. This one is saying the difference of 3 and p. So this is a comparison setup here. And the first number is 3, and the second one is p. And we are looking at this section here, what is different between the two of them. So our expression would be here, the difference of 3 and p. And generally what I teach is we have to do these in order. This is 3 and p, so it's 3 minus p. But with your models, be thinking about we have 2 things and we're looking at what is different between them, a comparison situation. So write an expression to show 4 less than the sum of g and 5. So I've got a 4 less here. 4 less than something. 4 less than what? The sum. So I need to have the sum of g and 5. And I want less than that sum. So I'll subtract 4. Now you might ask yourselves, hey, do I need the parentheses around the g plus 5? Well, if I follow order of operations, I'll do the sum first and then I'll subtract. I'll be okay going left to right following the subtraction or addition. So no, the parentheses aren't necessary. Is there anything mathematically wrong with that? No. No, there isn't anything mathematically wrong with that. So now we're going to write an expression to show 4 decreased by the sum of g and 5. So it says that I have 4 and I'm going to decrease it. I'm going to make it smaller. And I'm going to make it smaller by the sum of g and 5. So I'm going to have 4, and I'm going to make it smaller by the sum of g and 5. Now, reading the story, what is supposed to happen? Am I supposed to have 4 decreased by g and then have an additional 5 that I add on? Or am I supposed to decrease it by the g and 5 altogether? Now, hopefully your brain is saying, Mr. Ludlow, you're supposed to decrease that by the g and the 5. So I need to put in parentheses here to say do this part first, and then do the 4 decreased by. So should exercises 6 and 7 have different expressions? So in other words, should they be the same? Well, hopefully you're looking here and saying, yeah, these expressions look pretty different. They should not be the same, because one of them is saying 4 less, and the other one is saying 4 decreased by. They are different. One includes the word decreased by, the other has the words less than. The words less than give the amount that was taken away first, whereas the word decreased by gives us a starting amount and then the amount that was taken away. So thinking about the meaning of the words. All right, so take a moment and write the following in words. There are lots of ways to express these. Possible answer for number 1 here, the sum of m and k, or you could say m and k all together, or m added to k, or k, well, I guess m added to k. We got to do these in the order here. Second one here, we've got the sum of k and m, or k and m added together, or k and m all together. For number 3 here, we've got k less than m. So we had m, and we want less by the amount of k. We've got m minus k, and we have the difference of m and k. And for number 4 here, we've got m less than k, k minus m, and the difference of k and m. So is m plus k equivalent to k plus m? And is m minus k equivalent to k minus m? And there's the explanation here. These addition here, yes, they're equivalent to each other. Both of these expressions are going to evaluate to the same number. When I perform the operation, I will get the same thing. And that comes down to thanks to the commutative property of addition that we have looked at quite a bit in the last couple of weeks. Now, m minus k and k minus m, they're not going to have the same result. You would be starting with a new total amount. Substitution is a great way to look at this. If I've got k is 5 and m is 6, m minus k, 6 minus 5, is not the same as k minus m, 5 minus 6. The value of each expression is going to be different, so the expressions aren't going to be equivalent. And some examples here, 4 plus 6 is 10, and 6 plus 4 is 10. 6 minus 4 is 2, but 4 minus 6, and this symbol here is does not equal 2. So no, they are not going to be equivalent. So hopefully this lesson went well. If not, go back, watch it again, think about questions that you need to ask, things that you need to have explained. When you're feeling comfortable, go ahead and do your problem set. If you've got questions, make sure you talk to your teacher.